All right, hi everybody. We're going to take a look here at one of the crucial foundational models of micro and macroeconomics, the so-called production possibility frontier model, or production possibility curve model, as it's sometimes known. So here in one mathematical graphical relationship, we'll see the concepts of scarcity, trade-offs, production, unemployment, economic growth, lots of stuff to think about. In again, a relatively simple framework. So first part, we're thinking about kind of the scarcity problem from the point of view of producers, right? So we're thinking about the process of transforming factors of production, land, labor, and capital, using technology into output, goods and services, right? So for example, I'm combining my labor, my time, natural resources, my basement, and capital, my computer, to produce this video, right? That would be the very micro level production point of view, but the US economy as a whole is doing the same thing. It's combining our natural resources, our labor force, our factories, our tools, our machinery, using technology to produce all of the products that we consume. So the model will work either way, at the very, very micro level, an individual producer, an individual firm, or an industry or an economy as a whole. We're going to vastly simplify this process by saying, let's assume that the producer that we are considering has only two options for what to produce. You can produce product X or product Y. Don't worry, the results, the conclusions that we'll be able to draw here will generalize to a more realistic case, but it makes it a lot easier to keep it two-dimensional for being able to draw a graph. So what we can say is, if the producer is fully utilizing all of those resources that are available, right, whatever land, labor, and capital they have at their disposal, it's all being used in the production of either X or Y, right? Kind of the first conclusion of scarcity is, if you want to produce more of one of those products, well, you're going to have to take resources away from the other. There's going to be a trade-off. There's going to be an opportunity cost. Okay? That's kind of the first thing that we want to be able to capture here. Easiest, I think, to start this out with just a really simple example so we can put some numbers to it. So let's just pick an individual firm, say Tesla, and let's imagine that they only have two options. They can produce automobiles, generically speaking, or their residential battery units, their power wall units. Those are the two products that they have the option to produce using their fixed available resources and technology over a given period of time. So cars or those power walls, those battery units, that's the X and the Y. And again, an oversimplification, but for the purposes of the model, let's say that for a given time period, so for a given year, they can't increase their level of resources. They can't hire or fire people or build new factories. Over a year, that's unrealistic, but for a given period of time, a day, a week, a month, that is in fact pretty realistic. You have access to the resources that are available and you don't have time to adjust. But just so the numbers work out, let's imagine it for a full year. And let's further imagine that their combinations of feasible output look something like this. So just to make it somewhat realistic, these are in thousands, but we'll just refer to it in the units in the table. And each of these combinations, A, B, C, D, and E, again, represent full utilization of resources. So if Tesla decides to produce 0 batteries, what they're doing is they're using all of their resources in the production of cars. So the maximum number of cars they can produce in a given year is 2,000 units, 2 million cars, right? And if they want to start increasing their production of the X product, in this case, batteries, well, again, behind the scenes, what's happening is people are being taken from one factory to another, capital is being transferred, resources are being transferred from automobile production to batteries. So these numbers are going to come down as these numbers go up. And what we've done over on the right-hand side is simply plotted out each of those feasible combinations, A, B, C, D, and E. And the fact that when connected up, this shows a downward sloping function, that is the definition of opportunity cost, right? A downward sloping relationship. The only way to increase one sector, increase X, is to decrease Y. Okay. And then down here at the bottom right, what we're calling point E represents the maximum level of X production. So if no resources are being used in the production of cars, Y in this case, everything is being put into battery production. That 200 units is their maximum level of production. So again, by connecting those dots, what we're showing is all possible combinations of output that represent full employment, that are feasible for the firm. But you can also think about the position of that line as, the outer limit, the frontier of what is capable. You want to keep producing more of everything, but once you hit this line, all your resources are utilized, and that's as far as you can go. Okay. So all the points on the line, A through E, we would label as being efficient or representing full employment of resources. So just to pick one of those points, if you know what X is, so if we know that Tesla decided to produce 100 units of X batteries, if we know what this function looked like, or we had this table of numbers, we could calculate what is their maximum level of production of Y. So in this case, it would be 1,000. It would be that vertical point, the vertical height of the production possibility frontier. Point C in this case. Okay, so that's kind of the first thing we want to take out of this, what that position of that line represents. Further, thinking about a point like G sitting inside the PPF, so a combination of 50X and 500Y, any point like G represents an underemployment or unemployment of resources. Right? We could be producing more of both units. We have the resources available to do it, but for whatever reason, they're not being utilized at point G. So all of that area inside the PPF is inefficient or representing underemployment. And then all the points like F lying outside, above and to the right of the PPF, represent combinations of output that are desirable. You'd like to be able to produce more X and more Y, but are unattainable. Because again, think about the position of that PPF line as a brick wall. Once we get to that point, we've run out of resources, everything's being utilized, we can't increase from there. Now, going back to that idea of the trade-off or the opportunity cost, once we have this line plotted out or that table of numbers, it's a simple calculation to figure out what that rate of exchange is going to be. And what we're doing is simply tracking what happens as we move along from one point to another, that production possibility frontier line in this case, right? So picking point A as our starting point, if we move from point A to point B, again, we think about it as a combination, right? We increase X, we move to the right, but in order to accommodate that, we have to decrease Y, we move down. So all we're doing is tracking the slope of that function, right? So how many units do we increase versus how many units do we decrease in the other sector? So that rate of trade-off is the opportunity cost of X, and it is also the slope of the PPF. So it's the change in Y over the change in X, in this case from point A to point B, or from any one point to any other, because it's a linear function the way we've drawn it out. That ratio is going to be a decrease in 500, decrease of 500 units of y for every 50 unit increase in x, or a slope of negative 10. Each unit of x costs you 10 units of y. And clearly this is going to be crucial information from the producer's point of view, right? If you're trying to decide, is it a good idea for me to increase production or decrease production in one sector? Cost benefit analysis, right? You need to know what the true cost of that decision is, and that's going to be the opportunity cost. How many units do you have to sacrifice in the alternative sector? So if given a PPF example like this, and you're asked to find the opportunity cost, you can always find it as that slope between any 2 points on the function. So now we've drawn the position of that PPF as if it is a fixed position, but any change in access to resources, land, labor, and capital, or technology, the efficiency with which we can combine those resources, will result in a movement, a shift in the position of that PPF. And of course, realistically, that is going to be happening over time. So any change in access to resources or technology will have an effect on the producer's capabilities to produce. Whether they're actually going to change their production, that's a different question. But if you have more resources, you're able to produce more. Less resources, you're able to produce less. That's going to move the PPF. And it should make sense, right, that if we're pushing that PPF up and out away from the origin, a shift outward up and to the right, you're increasing the capabilities to produce. You're creating these combinations of output that were previously unattainable that are now within the new PPF. That can only come from increased resources or increased technology. And when you see that PPF shift inward, getting closer to the origin, the area representing feasible combinations is getting smaller and smaller. That's going to be due to a decrease in access to resources or a decrease in the level of technology. Not what you want to see. And it might look something like this. So again, starting with the original PPF numbers here, the X and the Y, if we see a shift inward of the PPF, one way to think about it is that for every level of X, Y is going to be decreased. The maximum level of Y that we can produce is going to be decreased. So here we're showing it as a nice simple parallel shift inward. Label it Y prime is kind of the height of that new PPF. And we can really think of this area here in between, I'm kind of scribbling through, the old and the new PPF. Well, those are all combinations of output that we used to be able to produce that are no longer feasible, right? They're outside the new PPF. Flip it around, a shift outward will have the opposite effect, right? For every X, Y is the feasible combination of Y is going to be increasing. And that area between the old and the new, in this case, the blue and the yellow PPF, represent newly feasible combinations of output. So if this represented an economy as a whole, right, you might say, okay, if we have immigration, right, people coming in, increase in the labor force, if we put all those people to work, we're able to produce more of everything. That would shift the PPF outward. Or increasing technology over time, making production, given our resources, more efficient, we would see that PPF shift up and out. In this case, if Tesla opened up a new factory, it would increase their production capabilities. Okay, so now we're going to complicate things a little bit and also make this a much more realistic view of the production process. Right? Up to this point, we've assumed that as we transfer resources from one sector to the other, X to Y and vice versa, that it didn't really matter what the land, labor, and capital was producing. It was all kind of homogeneous. It was all the same. Right? Well, in reality, of course, some resources are much better suited, much more efficient at producing one type of product than another. In other words, they are specialized in the production of a particular sector, a particular product. And that goes for labor, obviously, right? I'm marginally able to do only one thing, right? Talk about economics, right? If you put me on an assembly line to produce an automobile, I would be totally lost. I would not be nearly as productive in that sector as I am here. Again, even that, who knows? Same thing goes with capital equipment, right? You can't take a factory, a piece of machinery, a tool that's designed to produce automobiles and say, oh, well, let's just use that to produce batteries now. It's not that easy, right? So with the assumption of specialized resources, we have to think a little bit more about how that trade-off, that relationship, as well as how shifts in the PPF are realistically going to operate. So again, from our example here, we think about the resources that go into producing modern batteries, things like rare earth metals, lithium, and cobalt, absolutely crucial to producing those batteries, but they're really not that helpful in producing most other products, right? So if you have greater access to those rare earth metals, it's going to have a big effect on your ability to produce one product, batteries, but not really change your ability to produce other things, tires or axles, right, that go into the production of automobiles. In more general examples, right, increases in computing power and connectivity have large impacts on output capabilities in, say, financial services, but pretty minimal impact on agricultural products. So if those are the two sectors that you're focusing on, say for an economy as a whole, one might be shifting more than the other when access to those resources change over time. And that's kind of the first way we want to think about how this is going to change our view of the PPF or our use of the PPF. That most of the time, when that function is shifting inward or outward, it's not going to be a parallel movement of that line, right? It'll be more of what we can call an asymmetric pivot of the PPF. One sector is increasing or decreasing more than the other. The other effect that we'll get into in a minute is that drawing that PPF as a straight line with a constant trade-off as output increases in one sector isn't super realistic, right? So it's much more likely to be a non-linear functional form, and we'll look at the implications of that. But first, revisiting the idea of a shift in the PPF, this might be more of a realistic view of, say, a shift outward in the PPF. So say we have a resource or a technology that impacts only one sector, then the intercept, the maximum level of output in the alternative sector won't change, and it's going to be that pivot effect. Right? So in this case, say something happens that allows Tesla to produce more cars, but it's not affecting their overall battery production. If all the resources were used in batteries, there's no change, right? So that intercept effect, that intercept point isn't changing, but the level of Y for a given level of X is increasing. So we can really think of it as a change in the slope of the PPF. So say, for example, if we had what we'll call our Y triple prime column here, when we produce 0 batteries, when we put all of our resources into cars, we can produce a lot more than we could before. Maximum output is 3,200. And then same as before, as we increase our production of X, we move over and down, output decreases in the automobile sector. And we see, because that line is steeper now, the decrease is actually larger. In effect, the opportunity cost is increased because we got better at producing cars. So every battery means the transfer of resources is more costly. They could have been more useful now in the production of automobiles in that Y sector. The other, corollary here is, just like with the parallel shift, there is still this area, right, in between the old and the new PPFs that does represent newly attainable combinations of output. So that part is still the same, but again, it's not a symmetric effect. More increased production in the Y sector in this case than the X. So you should be able to handle an example like this, or if it was an increase in resources that only affect X and not Y, the line would pivot out flatter, right? Increasing the X-intercept, but not increasing the Y. So it all depends on the story. But this is the type of shift that's probably more realistic. And as we said, once the slope of that PPF changes, we need to recalculate the opportunity cost. Right? So in this case, along that new PPF, every incremental move to the right, increasing output by 50 in the X sector, now requires a decrease not of 500, but of 800 units in the Y sector. So a ratio of 16 Y per X, every X costs 16 units of Y. That's the new opportunity cost. And again, that should make sense with the story, right? Every worker, every tool, every piece of machinery taken away from car production is costing you more now because it was more productive in that sector. So the idea of a greater sacrifice by transferring more productive resources away from that sector. So now, the last piece of the puzzle, and the big implication of this assumption of specialization of resources, is that the PPF is going to be a non-linear function. The opportunity cost is not going to be constant, and in fact will be increasing as output increases. And so think of a generic scenario. We've got X and Y, and we're at that intercept point where we're producing 0x. All of our resources are going to produce Y. So we're up at that Y-intercept point. And now think of, okay, we don't want to just produce one thing. Let's start to move resources over from Y to X. And if those resources are specialized, some land, labor, and capital is really good at Y, some is really good at X, well, the rational decision maker is going to say, the first resources we move over should be the ones that are most efficient at producing X, the new product, and least useful in producing Y. So what that means is the first units produced of X are going to be the easiest to produce. They're going to have the lowest opportunity cost because the resources you're transferring are really, really good at producing X and maybe weren't so helpful at producing Y. It would be like taking me off the assembly line at the automobile plant. You're not really going to miss me, but hey, I can make a video talking about economics. So I'm producing something in the other sector, and I really wasn't helping in the previous sector. So that's going to be the most efficient use of those resources to transfer them over. The opportunity cost will be very low. And mathematically, what that means, right, is we get a big increase in X and a small decrease in Y. The PPF function is going to be very, very flat. It's going to have a low value of that slope. But that's not going to last forever, right? As we keep transferring resources over, we've already got the most efficient resources in the new sector. And if we want to keep producing, we're going to have to start to dig into those really productive, really efficient Y producing units. And we're going to lose a lot, right? You're going to take the 20-year veteran automobile assembly plant foreman and make him produce economics videos. You're going to lose a lot, even though he could probably do just as good as me doing economics. You're going to lose a lot of automobile production. That Y change, the delta Y, is going to be very large. So as that function starts to increase in its slope, it starts to get steeper and steeper. What we're going to see is this kind of classic concave or bowed out function that is the typical realistic PPF, right? So if we alter the numbers a little bit in our original example, we can see how we get this result. So the X column I've left the same, those 50 unit increments from 0 up to 200. And if we start at the same point we did before, 2,000 automobiles, and then we start to move from left to right, so from point A to point B, this is a more realistic way to think about it. The first 50 batteries that we're going to produce are going to have a very low cost. The resources being transferred are really, really efficient. It doesn't take you much to get those 50 units produced, and you're not going to lose much in the alternative sector. You only lose, say, 100 units from 2,000 down to 1,900. So the slope, that ratio, delta y over delta x, down 100 over 50, is a ratio of 2. So 2y for every x that is gained. And then moving one more increment over from point B to point C, the delta x is still the same of 50, but now we've lost 300 units of y. And why is that? Because the resources being transferred are assumed to be more useful in the y sector. We've taken the best x resources already. The next installment is going to be a little bit more costly. So that ratio, the delta y of negative 300 to 50, 6 units of y for every x produced, and so on and so forth. From C to D, that line it's no longer aligned, that function, right, is getting steeper and steeper. That delta y has increased. Now we go down from 1,600 to 1,000. We lose 600 units for the 50 units gained, so a cost of 12y per x. And then things get really costly going to the extreme case from point D all the way to point E. Production of y drops all the way from 1,000 to 0. So that ratio of 1,000 units lost for 50 units gained is going to be a 20-to-1 ratio. So the first units of x cost us 2y each. The last units cost us 20. So guaranteed exam question, right? You'll see a PPF that's shaped like this, and the question is, why? Why does it look like this? Why isn't it a straight line? And the answer is resource specialization, right? The realistic assumption that land, labor, and capital is better suited at one sector production than another. So to bring it back to our original kind of interpretation of the PPF, everything that we talked about before still stands, right? So in thinking about how to interpret a position inside, on, or outside that non-linear bowed out PPF, it's exactly the same. It's still the case that every point on the PPF is representing full employment of resources. Everything inside the PPF, let's say in this yellow area, is inefficient unemployment or underemployment of resources. And still anything outside that frontier, that function, is unattainable. And how do those unattainable combinations become attainable? Same idea as before, right? We need to shift out the PPF, and it would just be, instead of a parallel shift of a linear function, we can just think of that frontier, that bubble shape, moving outward. But the story is the same. The farther away from the origin we get, the more combinations of output are attainable, and that's only going to come from increased access to resources and technology. And when you see that PPF shift inward, boop, 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 combinations of output previously attainable are now unattainable. That's going to be coming from a decreased access to resources and technology from PPF 1 to PPF 2. Okay. So to wrap this up for now, we come back to this model a lot, right? Because it's so foundational. It gives us just such a convenient way to think about all of these issues. But as far as where we're going to go from from here, remember that this model is representing the constraint that's applied to the producer's optimization problem. They would like to, maximize profit, produce and sell as much as possible, given their resources and technology. So we know that the answer to that optimality question, right? How many units of X, how many units of Y should we be producing to give us the maximum level of profit? Well, we know that the PPF gives us all the possible answers, right? The best combination of X and Y to produce has to be somewhere on the PPF, right? Because if you're inside the PPF, well, you're not producing as much as you could, and we can't attain a combination outside the PPF. So inside is inefficient, outside is unattainable. On the PPF is going to be, right, our set of efficient full employment combinations of output. And on that PPF is where the profit maximizing optimal solution is going to lie. But where, we can't say, right? That's going to depend on the demand side of the equation, right? Ultimately, where we're going with this is, well, once we produce X, what's the revenue that we could gain from selling it? What is the consumer's willingness to pay for that product relative to Y? That ratio will tell us where exactly on that frontier is going to be optimal. So we haven't quite answered that question yet, but we've definitely narrowed it down with the PPF, and we've got a good idea of how it's going to change over time, shifting in, shifting out, and again, the nature of that trade-off, that opportunity cost along the PPF. So progress, stay tuned for where we go from here. Thanks.